Hello, this is Max NG7M back for video number 5, which will describe the calibration steps numbers 6 through 9 for an HF amplifier. It's the B26-RF2K+. If you found this video, you can find the previous videos that cover the earlier steps, which there's one on my YouTube channel. And hopefully if you like the videos, click on like and you'll find this useful. This is an excellent project. I need to talk a little bit about the manual and the state of the manual as of, we're 3 weeks into the month of August 2018. And as always, and I'll mention this in every video, hopefully if I remember, do not rely exactly on everything that I show you. If there's any mistakes or anything, it's my fault. And you'll want to always refer to the manuals, read the manuals, get the latest manuals, make sure you're dealing with the correct hardware versions or PCB versions, etc. for your amplifier kit, and ask questions on the RF-KIT forum, and just make sure you're well prepared for the calibration once you get to this point. So consider these videos reference videos. I can't obviously be held responsible if you make a mistake or something goes wrong. I'm just a happy buyer of the kit at this point, and so I thought I'd put these videos together. So between, it's been a few days, I've been out of town on business, but Reinhardt DH3 NAB contacted me, and on a couple of my videos I have my high sophisticated presentation screen that you can see over here on the right side. I was still crediting off the top of my head, it was DH7NB Wolfgang, who apparently was part of the project a couple of years ago, but over the last couple of years, Canute, Delta Fox 9, Quebec Alpha, and I'm pretty sure I'm saying his name close enough as a North American can get. It's Canute, Kilo November Uniform Tango, has been working the magic in the last 2 years on the software that duplicates the display, whether you're in VNC, which I'll be using in the video here, or clearly on the screen that's on the front of the amplifier, the 7-inch touch display. So kudos to Canute, and also Chris, of course, DL5NAM, and NU6 X-Ray Mark has helped out with the documentation. And I want to mention Neil Kilo 3 November Charlie here, because he combined a couple of the manuals that was causing some confusion, and I'm sure there'll be even an update further. But as of today, which is I've got a slow memory, the 23rd of August 2018, you can look on the forums for under the B26 RF-K or RF2K plus amplifier and search for Neil's contribution. He combined a supplementary manual for image 055 of the software, which includes some simplified and more accurate calibrations that we'll actually be touching on that in this video. And I don't know the backstory there, but I think Mark delved in and found a easier way to do some of the calibration, where previously you use a digital voltmeter to measure some voltages, but it wasn't quite as linear on the watt meter display. So not to get too far into that, but the manual I'll be talking about, and I think I've covered most of this here, looks like this. So if you find that manual, I didn't see it in the file section on the forum quite yet, but you can tell the difference on the manual. Let me get me out of the way here. Sometimes I forget to move stuff off the screen. So this is actually the older version. So if you see a manual that looks like this, you'll want to get the combined manual, and it looks like this. And so it'll have the top here, it'll have August 2018, where the previous manual had in German it was if my pre-prep school German is correct, January, February, March, it was like May, M-A-I, I can't remember how to pronounce that, my rudimentary German, but it'll have August 2018. And if you scroll down, this is the effort of Neil K3NC. You'll see the bigger fonts here for the steps. So steps 1, 2, 3, 4, 5 we have already done in the previous video, and they have not changed. So no worries there. And today we'll be focusing on steps 6 through 9. And to do that, I'll assume that you already either have the front of the amplifier in front of you, but it's going to be a lot easier to adjust those pots if you remove the front of the amplifier, lay it down in my opinion, and you use VNC. So it'll just prepare you to remote into the amplifier anyway. If you're going to spend this kind of money on an amplifier that has these really cool remoting capabilities, you may as well see some of those features now. So I have VNC already running here. I'm going to pull it up, and we'll move my sophisticated splash screen software off the screen there. And I've got a Slack, looks like I have a Slack instance going there. Let me shut that down. So this right here is the front of the amplifier right now. And I'm going to do a little bit of digression here, a little bit. Just right now I actually have it hooked up with the CAT interface. And I think if I continue to stay motivated on this after the calibration is all done, and I do a calibration video on the high power, I'll do a video on interfacing with the CAT data from your rig. And so right now I'm actually using the CAT data directly from my K3. So if I go into the menu and I go to hardware, the rig control, you'll see I've got everything set to Elecraft K3, and I have serial data going directly into the Raspberry Pi 3 Plus in my case, and the software that we're running here is reading, it's polling for that K3 CAT data, so the software in the amplifier knows exactly what frequency you're on. So and this is a little bit of a digression, I know, but if you can look up here where my cursor is, see if as I'm tuning the rig, I'm spinning the VFO here with my left hand, you can see the frequency change here. So I received some comments, some constructive comments really. Some guys are not going to want to get into all the rig automation, and I'm totally digressing now. But to me, it's part of the protection capabilities of the amplifier and the effort that's been put into the software and the protection of the amplifier begs to have your rig control at a minimum telling the amplifier what band you're on. And especially if you're using the antenna tuner, you should be telling the rig, what exact frequency you're on, so it can automatically adjust before you key the exciter or your transceiver. So just a bit of a digression there. I am using CAT control here, and that'll in step 7 or 8, step 8. It makes it easy to go through the bands, and we'll talk about that a little bit more. So let's get started here. Step number 6 right here is very important, and it's critical you read through the setup here, because you will need to have the PTT, the RCA connector, hooked up here, because we need to configure or set up the software that's built, that's running on the Raspberry Pi, so it knows what frequency you're on, because there's a frequency detector built into the amplifier. So if CAT control isn't working, if everything else is not working, there's still a frequency counter. If you excite the amplifier, if you key the amplifier, it will still detect what frequency you're on and select the proper low-pass filter, and all the relays will switch. And in the case of the antenna tuner, it'll automatically tune the antenna for that particular frequencies. But ideally, as you tune your transceiver and change bands, it'll send that data to the rig. But anyway, step 6 is to calibrate an offset so the rig knows, it obviously has a local oscillator of some sort that's very close to frequency, but this calibrates an offset based upon your rig's frequency and the transmitted frequency, so it knows exactly where you're at. And so we'll go ahead and do that. So the dummy load, I'm not going to go through all these steps here. You got to read through these. And the first thing you'll want to do after you get the RCA connector hooked up, and again in the previous step you made sure that RF was passing through the amplifier and you're hooked up to a dummy load. So all that continues. This is just continuing right on after step number 5 in the previous video. So the first thing to do is, you'll notice right now I have the antenna tuner in my amplifier, which I think most guys buy it with that, and we need to disable that. So we'll go to the menu here and go to settings, and the tuner is enabled. We're going to click that to disable and close here, and then you'll just see the logo for RF-KIT right here. One thing that's a little tweak in the software is I notice after you restart the software, it may show that the tuner is enabled when it's not. It's just a refresh on the screen there. So anyway, you need to disable the tuner. That's one of the steps here. And and then we're going to tune the transceiver here, and you'll be able to see it now without having to show my exciter. But I just switched up to 18 megahertz, and you're seeing this change right here. Automatically, see it just switched to 21 megahertz. You may have heard the relays click in the amplifier. And now we're on 24 megahertz. And now we're on 28 megahertz exactly. And so if I tune up, you're going to see it tune. And my cat Clyde is in the background again, so you may hear Clyde yowl a little bit. Everybody tells us that it sounds like a young child, but it's my 14-year-old Bengal cat here. And so we'll try to keep him quiet. He's a good old cat, friendly guy. So we're going to tune exactly to 28 megahertz here, and the instructions show ideally that you're going to key the amplifier with 1 or 2 watts, but it's clear, a lot of transceivers don't go to that low power. My K3S clearly does, and so I have the tune set up. If I key it up for tune, it's going to be 1 watt. And so let me pull up my virtual watt meter display for my LP700, which is right here. And so when I key the amplifier, right, we're going to see it key up to 1 watt there, and I'll unkey. And if you continue on with the steps, this step's pretty easy. You simply go to the menu, and so you can see the cursor here. You click on calibrate frequency, and it'll pop up a screen here that says set the frequency to 28 megahertz and use AM or CW. So the tuning on a K3 is a constant carrier, like a CW carrier, and just go ahead and transmit a few watts. I did 1 watt here. It's still keyed, and then while transmitting, you click OK, and a new correction factor has been determined. So the internal reference, I don't know all the details there, but apparently it's a hair high, so the correction factor is a little bit less than 1 here, just a fraction less than 1 to correct the frequency internally. So you go ahead and click OK, unkey your transceiver, and so we're done there. And I can quickly do that again. Just to go through it a couple times, it's not going to matter. So I'm keying, and I clicked OK. There's the correction factor again, and I can click OK, unkey the transceiver, and we're done. We're done with step 6. So close this window, and now as we get into step 7, step 7 is really very, very simple. But I like the fact that the documentation goes into details on the different capabilities of letting the amplifier know what frequency you are on. At a minimum, obviously, we just corrected the offset for 28 megahertz there. And now we're just going to run through and take a look at the low-pass filter and make sure all those relays are switching. So to do that, I don't need the watt meter anymore, so let's move VNC up here, the display of the front panel up here. I'm going to turn on my second video camera, and it's showing the front of the amplifier right now. I'm going to turn this, so this is live. I haven't scripted this yet. So I'm just going to kind of show, hopefully we'll be able to see some of the LEDs. So I'm showing you here, right, we're looking at the low pass filter board down here. And I've got a little light on there. It'll probably be better if it's darker a little bit. So let's talk about the CAT control a little bit more. And I know there was a comment about all the techno wizardry and everything. I disagree. I'm big into the automation, so to me it's very important. The manual goes through it, and certainly you can always just use the frequency counter and key the amplifier to get the amplifier on the frequency that you're going to be transmitting on. And if we look at step 7 here, the test the low pass filter section, read through the different options you have for controlling, letting the amplifier know what frequency you're on, which will select the proper low-pass filter. Right, there's 6 of them across the ham bands, and several of the filters are used for multiple bands. So we're going to talk a little bit about the control there. Again, I'm verbose here, but I think it's worth it. Number 1 is the universal interface, which simply is using the frequency counter when you key the amplifier. Within a split second, some number of milliseconds, the frequency counter, now that we have it referenced to a known frequency, which was 28 megahertz, it will determine what band you're on easily enough there. I'm not going to test that. I'm just going to show you the CAT thing because we're going to move on through here. So that is your bare bones interface, and if the amplifier can't determine that it's getting band data in any way, any shape or form, it will default to the universal interface, which is actually shown up here. So instead of CAT here in green, you'll see universal there, and you can actually switch between CAT and universal by clicking on that. I'm leaving it in the CAT control for now. So you have universal interface. That's the simplest. If you're in a hurry and you don't want to take the time to hook up the rig control, just go with number 1. Number 2 is the Yaesu binary coded decimal interface, where you have 4 control lines with voltage on them, and so it's just a 4-bit interface, and so you can determine up to 16 bands, right? 15 or 16 bands with the 4 bits, and that's that interface, and so that comes off the band DB9 data, and you'll have to look at the right pins there. Number 3 is the ICOM interface, which uses voltage levels from an ICOM transceiver to select the what bands you're on. I've owned ICOM transceivers, but the only one I own now is in my truck. And so I didn't use the ICOM interface, and I'm using number 4, which is the CAT interface, which determines the band frequency from the transceiver. And the most integrated, again, I'm showing you this again, is if I go to the rig control, I have selected CAT right here, and I have the manufacturer set to Elecraft, and the rig is K3, and I have a FTDI chipset USB serial port adapter plugged into the back of the amplifier. And so the Linux operating system has configured that serial port. In the Linux world, serial ports are TTY devices, and so that is USB device 0 here. So a little bit of a digression here, but the CAT USB port is just an extension of the Raspberry Pi 3 Plus. And I was a little confused on that, but I understand it better now. And so the typical baud rate for a K3 is 38.4 K baud, so I have that set. And it's up and running. I'll try to remember to do another video on that. So anyway, so we got the CAT data going, right? And as I tune, you're going to see it tune up here, right here. You can see my cursor. And so I don't have to transmit to switch between the low pass filters in this case. So The manual has a couple pages on it. It talks about how to do this with the universal interface. And it's a very simple test. Some guys may think this is way too much to actually just check to see that the low-pass filters are being selected. But again, I'm big on the rig control. The designers of the amplifier and software are clearly big on it too, especially in like an SO2R station. You want that amplifier to know where you're going to be before you key. So there's a section for each CAT control device, and so again, we're looking at the CAT interface, and so it talks about setting up and using the specific rig control. In my case, it was the RF-KIT again. And a lot of this is a lot of information for some guys to swallow, but just take your time, ask your buddies at the local club meeting, they'll help you get that figured out. And all we're going to do now is, well, actually it does have you transmit, I guess, even on the CAT control, but the main thing as you go through the bands is we want to see the different band low-pass filters. And so I'm deviating a little bit from this instructions here because this is kind of live, but I'm in standby right now. But as I change the band data in my case, let's see if I can, like if I go down, so you'll see it, you know, within a second of me changing the band control on the rig. So I think I'm going down lower, and do you have to be in operate? I can't remember. I was hoping you'd be able to see the LEDs. So you can right there. So there's an LED for 6 meters. So there I just switched to on 24 megahertz, so 24 megahertz and 28 megahertz you can see on the screen there. I'm kind of multitasking here, or using the same filter. And then as I go down to 24 megahertz, it's not going to change. If I go down to 21 megahertz, it looks like it uses the same one. If I go down to, this is common, if I go down to 18 megahertz, we're now on a new low-pass filter. You can see that changing in there. And we're going to go through, so there it's down, I'm switched to 10 megahertz, which is probably going to be the same low-pass filter as 7 megahertz. Right, nothing changed. Now we get down to 5 megahertz, and now we're on the last one, 5 megahertz. I think has its own, and then we're going to go to 80 meters. Well, 80 meters and 5 megahertz has the same one. And then 1.8 megahertz is going to have a dedicated one there. So close enough. You can see how that is working there. So now I'm down on 160 meters. And I'm not going to go through all the bands, but the other thing that they want you to do in the manual, now that I'm reading this, is confirm that you have a low SWR across all the bands. So I'm on 160, and you know, you want to transmit, so there is 1.2 watts, right? I could turn up the, you know, you just want a low SWR. So now I'm going to go up to 80 meters, 3.5 megahertz. I'm going to transmit low SWR. And yes, this is a little laborious, but with operate on, you're making sure that all those low pass filters are showing a proper SWR with a 50 ohm load connected. So okay, 80 meters looks good, right? Low SWR. And we're going to go up to 60 meters. I don't even know if that's a valid frequency there. I think it is. So anyway, low SWR there. I'm in a dummy load, so it doesn't matter. And here we are on 40 meters, workhorse band there. We're going to transmit. And looks good. And now we're on 10 megahertz, transmit. SWR looks good. And so I'm just going to laboriously go through these. 20 meters. And you should go through all and make sure all those low pass filters are working as designed with the relay switching. Okay, 20 meters and 17 meters, 18 megahertz, looks good. And up one more, 15 meters. You can hear those relays changing as I change bands on my K3S. So now on 24 megahertz, I'm going to transmit. Looks good. And let's see here. 24 megahertz. Did I just do that one? Got a short memory. Now we're back up to 28 megahertz, 10 meters. Looks good. And we're going to go to 6 meters. There we are, up in the kind of the sideband area of 6 meters transmit. And it looks good. Another reminder, you see that the SW or the power output, even at 1 watt, varies, right, by plus or minus 20% on a high-end meter, right, on a LP700. That's very good. So it's just to show you, it's tough to get a very accurate power meter. You know, this will be very good. So keep that in mind as you're calibrating. I went over that heavily in video 3. All right, so one other thing. The manual talks about once you're transmitting, I think it's wrong because we've got the bias disabled, right? So I don't have bias turning on the amplifier deck. So the manual actually talks about the LEDs, if you can see there, when you transmit. If bias was enabled, that would come on. But there is an LED towards the back there that is on, and it's always on. So that was a little confusing in the manual there. Okay, so you know, maybe somebody can comment in the video there on that particular step. A little confusing to me. I know later on when you enable the bias voltage, when the amplifier is keyed and RF is going through, you'll see those LEDs light up for each of the LDMOS devices. So, okay, hey, we made it through step number 7. So let's move on. This gets a little more interesting. So step number 8, we're going to, it's actually been simplified. So if you have this version of the manual from, you know, Neil, where he combined the other 2 manuals, let me just quickly show you that. I know I've shown that in other videos. And if you go to the files section here, RF2K Plus, and I think I might be able to, let's see if I can get that to go bigger here. Let's see. Yeah, that doesn't look right. I thought I could zoom in, but apparently not. So I won't worry about that. But there's, under the manual section, the manual that I'm showing you here is a combination of this document here, the tested calibration procedure, version 4, revision 7, dated February, in the file area. And it also has merged into it this particular file right here, which is the image 055 update V4 Rev 2, which is from May of 2018. So again, the manual Neil has delivered to us combines those 2 documents, and it makes my life a lot easier because you don't have to figure out which steps need to be replaced that simplify some of the calibration. So we're looking at number 8 here, and so this will be adjusting a couple of multi-turn pots on the B26 controller all the way clockwise, and then we're just going to back them off a little bit based upon a reading that's in the debug screen on your display or via VNC. So that's what we're going to do right now. So I'm going to move the amplifier over here a little bit. And let's see. Let's get that out of the way. I think I can make this a little bit bigger here. Oh, I got to turn that display on. Thought it was on. It is on. Come on. Okay. There we go. Okay. And we're just going to be dealing with, and maybe it's easier if I pull up. I have on my website, and there's a link in the description of the video. I've got some reference images that we're going to show for calibration, and we're going to be looking at, now I'm over here again, you can see my cursor's moving around. We're going to be turning R19 and R20 per the instructions, right? R19 and 20, just all the way clockwise, okay, clockwise, not counterclockwise, but clockwise. So let's just quickly do that. And these multi-turn pots, so let's do R19 first, right, the one I'm on. And once you get it all the way clockwise, you can typically hear it click, which you probably won't hear on the video. Now I'm going to do R20. It's clicking. Maybe if you have really good ears, you can hear that if the microphone picked that up. So now R19 and 20 have been turned all the way clockwise. And let me minimize that. Now we are going to pull the VNC screen back up, and I'm going to hide this view here. Let's see the second webcam. So here we're back here, and we want to make sure you are in standby. Select standby on the TFT screen, right? Because I was previously in operate as we were testing those low-pass filters. So now we're in standby. And let's see here. I want to make sure I didn't. I think on one of these steps we switched back to 10 meters. so I don't forget about that. I'm going to go back to like 14 megahertz, 20 meters. Okay. So what we're going to do here is we're going to go to the menu screen right here. Menu. We're going to go to the debug tab. And there's a lot of information on this screen. And we're going to look at A4 right here. A4 power out forward. Okay? And so once we've keyed on this number, I'm going to key the transceiver. And that's 1 watts. And let's see here, the instructions say take that right up to exactly 30 watts, or as close as you can get here. Let's see. So I'm just increasing my power up. So I'll once I get to this range on the K3, I only have 1 watt increments, so it's like either just below 30 watts if my meter is spot on, or just right above there. So now I've actually keyed the transceiver, right? And you'll see right here, A4 power out forward is 587. We're going to turn counterclockwise now, A4. So that value right there, which is 588, you see it right there, we're going to turn counterclockwise R19 until that decreases by, let's say, 5 or 6 right there. We want to keep it at its highest point when it starts decreasing. Now there's some slop in the pot, so it's going to take maybe a turn before it starts decreasing. So let me get my little tool into the pot, and I got to turn that screen back on here and move it. Let's see. Okay. Well, there we go. Okay. All right. So so you'll see this. Again, we're looking right, hopefully you can see that, but it's A4. So I'm going to start to turn counterclockwise, and right now it's 590. I'm going to take it down to about 585. And so I've turned quite a bit, and it hasn't started dropping yet. And oops, see my little tool slid out there, which is so there, it finally started dropping. Did you see it there? So now it's at 5. Hopefully you can see that on the screen. That's pretty tiny. And so the backlash or slop in the pot there, see, so I actually turned it back up a little bit, so it's you know, just so you turn it so you see that move about 5 to 10 digits as those newer instructions specify. Okay, so now I'm going to unkey, and what we're going to do now is we're going to reverse the input and the dummy load, right? So the exciter input and the dummy load are going to be reversed on the back of the amplifier. So I'm going to come back here, and I mean this is obvious, right? I'm going to come back here and just reverse. I'll make you sick. But here's the exciter input, and here's the dummy load. I'm going to reverse those two coaxes, okay? And then we're going to do that other pot. Okay. I guess if I was motivated enough to edit these videos, I'd cut some of this out, but you can fast forward if you want. Alright. Okay, so same routine now, except we're dealing with the other pot, which is, let's see, R20 here. Okay? Minimize that out of the way. I keep the desktop. All right, key the transceiver now again. We're going to go up to 30 watts drive. And okay, close enough. Close enough for the girls I date. I'm married, so it's close enough. Now we're going to do the same thing, right? So we're looking at A5, alpha 5, power out reflected, which is currently 585 or so. So we're going to drop that down to 580, maybe a little less than 580. Okay? Coming in on R20 and just going counterclockwise again until A5 goes down to about 5, and wow, I slipped out again. 580. There we go. It started to drop. So there, we're down to, you know, 579, 580, right in there. You know, 5 to 10 digits. And I think that was from Mark. Okay, so unkey the transceiver. And so that step is done. That's step number 8. So high five, right? Now the last thing, you want to return the transceiver and the dummy load back to the way they were, because we're going to reverse them again in the next step actually. So, okay, so back to normal setup here. Alright, okay, and hopefully I can knock out this, we'll knock out step number 9 here, and this is live on this one. I haven't gone through this with the new way to do things, and there's kind of 3 things that are going on here. So we're into step number 9 now. We're going to calibrate the SWR bridge, and so, you know, the amplifier is unkeyed. And we're on the debug screen still. Got that up. And we're going to switch to 10 meters or 6 meters. I'm just going to go put it up on 10 meters. So I'm up the 10 meter range here. And if I close the debug screen, you can see that we're at, you know, 10 meter range. I'm still in standby. We're going to go back into the debug screen. Okay? And we want to make sure that it's in standby mode, right? That's in the calibration instructions. Standby red right there, okay? And the first thing we're going to do in step number 9 is we're going to key the transceiver up to 30 watts. Here, this is forward, right, we've got everything back to normal. The exciter is in the exciter SO239, and the output is coming out of antenna 1. And so I'm going to put that up to 30 watts drive here. Okay, and okay, so 30.6 is good enough. Might drop a little bit as the RF transistors heat up a hair on my K3S there. Okay, so we're keying the transceiver. We're on 10 meters. Everything's good. And now we're going to look at the A5 power out reflected. We're going to adjust the coupling capacitor. And let me show you, let's see if I can get the, I did this earlier. I think I don't have any. So the coupling capacitor is right back here. Okay. And I can show a, hopefully that'll, I think you can see that from there. Yeah, you can actually see it from here. It's right here. And if I pull up the reference images, go to, it's right here. So if we come over here, oops, let me go back, right here. Hopefully that's capturing my cursor. So we'll be adjusting that, and we'll be dipping the value of alpha 5 power out reflected. Okay. Okay. So I am going to use. Where's my little guy here? So we're looking at power out reflected, which is 134 right now, and it's going to be tough maybe for you to see this. I wish I could zoom in without losing the desktop. It's kind of hard. Let me try that one more time. Oh, that worked. Let me move that up. Or what's going on here? Is it's, yeah, I can do that. Okay. It's just a little squirrely on the screen there. So we're going to be looking at A5 power reflected. I've still got that poor K3S keyed down. So now we're going to dip A5. Okay, see how it's changing? So you can see right here, A5, it was at like 134. We want to dip that to its lowest value. Boy, and it's very sensitive. So there I've got it down to 98, 90. Oop, there it's going back up. So I'm going clockwise and counterclockwise to dip that value right here. See, it's 92, 91. Oh, now it's going back up. 94, 93, 92, 91. Going back up. About 90 is about as good as it's going to get. Okay. There's a little backlasher. Might be a hair of so 90. Ooh, see, boy, it doesn't take much and you'll get it not dipped. Okay, so that's pretty good, right there at 91. And if you have a ideally you want to do that with a something that isn't magnetic or a lot of metal there, because you'll it might impact the dipping of that. So I dipped A5 there down to 91, and I'm glad I actually zoomed in the screen there. That makes life a lot easier. So if I zoom out, there, we're all the way out. Okay, so we just completed this. Okay, so now we're going to we unkeyed the transceiver. Okay, we're going to go back to the 20 meter band. So now, show you here, I'm on the 20 meter band. You could hear the relays click there as I changed bands on the K3S. And okay, so now we're going to adjust the we're going to the standard screen, key the transceiver with exactly 30 watts of carrier, adjust the forward pot on the SWR bridge for 30 watts of forward power on the TFT screen, okay? And this pot is backwards, so let me show you a picture of this pot. We're now looking at the reference images where it's this pot right here. Hopefully that cursor's coming through here so you can see forward adjustment. And the old instructions, you would adjust this potentiometer to 2.9 volts at 30 watts, measuring the voltage off this the pins over here. But this is a more linear accurate thing. I'm not going to go into the details, but I'll be adjusting this pot right here with a little teeny tiny screwdriver, because that's a very teeny you know, inset screw on that multi-turn pot. Okay, I mean, I know this is getting verbose, but I'm going to key the transceiver, and we're going to, it's probably already pretty close because I went through the earlier calibration before I left on that business trip. So here, right, we're looking at the watt meter, and it's up to 30 watts there, but you can see it's actually off here. So now I'm going to adjust that pot and watch this right here drop down to 30 watts. So it's about 40 watts right now. So now I'm in, let's see. Okay, I still have that screen going there. You can see me coming in here with this little blue-handled screwdriver. And again, this is backwards, so if I want to reduce what you're seeing on screen, I'm going to go clockwise. So I'm going clockwise. And see that value's dropping down there on the VNC screen, okay? Right here. And so we want that down to right at 30 watts. According to my LP700, I'm at 30.6 watts. I'm still going clockwise, so and now I'm, so it's closer to 31 there, so I'm gonna, that's pretty darn good there. So success, right? Forward power reading from the K3, it's right 31 watts, and the watt meter on VNC in front of the amplifier is at 30 watts. This is very important, so there's a reference in the amplifier for the protection circuits later on, right? There's, you know, voltage detection, I suspect. So when you overdrive the amplifier, that may not be related to this, right? We're calibrating the SWR bridge, but the accurate watt meter is quite important. All right, so we're almost done with step 9, and I can get this video posted. So now we're going to reverse the antenna, coax again, and you'll see me back here doing that because I still have that video on. So I've got my little red electrical tape on the hot one, right, the one coming from the transceiver, so I don't get them mixed up. And now it's the same routine, but with that other pot here. Let me turn this video off. So I'm looking at the manual here. So now we're going to use the other pot, which is this one. Right here, reflection adjustment, right down here. Get my cursor there. Hopefully that is coming through. I believe it will. This pot right here. It's the same routine. So now I'll turn that other video on. Key the transmitter, bring it back up to 30 watts drive. Could have saved a little time, I could pre-adjust that, but okay, so we're effectively the same one. So now I'm diving back in on that other pot there that I showed you on the reference image, and we're going to go And so here on the VNC display, right, we're looking at reflected power right here. It's at 40 watts. And so we're going to go clockwise right here because it's backwards to reduce that down to 30 watts. And it's dropping there, did you see? Dropping down 34, 33. And I think this is big enough. You should be able to see that right where that cursor is. 32 and 30. I'm going back the other way, getting past the so want it right at about 31 watts. I mean, it doesn't have to be perfect, but hey, you can tell I'm into the accuracy there. And we'll call that good. All right, unkey the transceiver. And guess what? We're done with step number 9. And in the manual here, let me turn off that other video. So we just completed step number 9, calibrate the SWR bridge. And oh, by the way, I should have mentioned, I had the SWR bridges shielded, and I had the cover already off, but it's normally taped on with some electrical tape. I may use a little zip tie there, but anyway, that was off. So you have to open that up, obviously, right here. So we are done with number 9. And the last thing important, right, we're going to switch back. So for step number 10, if we do any transmitting, we got to get back to normal exciter on the transmitter input here on the back of the amplifier, and the dummy load on the output. So with that, I think we can claim success on those steps. We can minimize this, and I'm sure you're excited to see more of me again here. And I have a hard time with that. All right. Hey, call it good, and look for the next video, video number 6. Hope you enjoyed that. If you liked the video, give me the thumbs up. And I don't think it's going to take me too long to get to the next video. I think I'll make it through everything clearly, by the weekend. So 73 for now from Max NG7M.